Hi, I'm Paul Battaglia, and this is section 4.1, radian and degree measure. In section 4.1, you'll probably find that students have vast knowledge of degree measure, but now we have to introduce this new radian measure. So we have to kind of talk about how to at least start the lesson off. So Brittany, what do you like to do, or at least talk over with your students?
Like you were saying, the students are familiar with degrees.
Okay.
So I like to start with just a review of degrees and show them that, and then transition into radians.
Okay.
Yeah. And then after you do that, that helps sort of segue yourself into introducing some of the definitions that happen earlier in the section.
Right, I think that's a good idea. And you know, one of the things I like to do with my class is to try and get a little activity, get them even out of their seats a little bit, playing with each other in terms of learning how to make that conversion from degree measure to radian measure. So we have a couple materials here we're going to run through with you, and then we'll kind of model the activity so teachers can see it. So the first thing you would need is some string. After that, you'll need some scissors and some colored pencils, enough for each student. And not only that, but I like to give each student 3 colored pencils because of all the folds we're going to be making. Now I have markers here so that we can see it a little bit better. But what we're going to start by doing as a teacher is we would take the string and cut it to the length of the diameter of a paper plate. And you'll need paper plates as well, obviously. So once we do that, I'm going to take that diameter, cut it in half, because that's really what I need. I need a string length that is 1 radius length. So let's do that real quick. All right. So now that that's done, we're going to put the string aside for a little bit, and we need to make some folds. Okay? So what we'll have you guys do is we're going to take our plate and we're going to fold it into fourths. All right? So let's do that. Try and make the creases as distinguished as possible. We're going to actually trace those in a minute. Okay, so when you're done with that, you should see basically what amounts to quadrants. And that's what we're doing. We're kind of forming a pseudo-coordinate plane right now, Cartesian plane. And we're going to be labeling not only the angles as we go around, but the axes as well. And that's how we'll start off. So pick a color and label the x and the y-axis. Just trace it out through the creases. Now, if you like, and you think it would help your students, feel free to hand out rulers as well, or some type of a straight edge. And after we draw or trace our x and y-axis, we actually probably want to label them as well, just so we don't get confused as we go and rotate around our plate. Because remember, as we're picking up the plate, you know, depending on how we pick it up, the orientation will be all weird sometimes. So now that I've done that, I have x-axis, y-axis, and I am good to go. So we'll start nice and simple. What we're going to do is we're going to start here, and we call that 0 degrees. Rotate around, label 90 degrees, 180 degrees, 270, and then the coterminal 360 degrees.
Doesn't matter which color they use?
Not at all. In fact, I probably would stay with that first color for this one.
Okay.
And so after we're done, looks like that. Is yours looking okay?
I think so.
Perfect. Yep. Yep, good. Okay. So now what we're going to do is make another fold. Okay. So we'll fold it back into fourths again.
Okay.
Okay. The creases become more defined every time we do this. You know. And now we're going to fold it into what will be eighths. So we'll take our quarters and fold them in half.
Okay.
Really just trying to exaggerate that crease, because now what we'll do is when we open this up, we're going to pick a different color and trace those creases as well.
Okay.
Now, as a teacher, what you might want to consider doing is prepping some of this beforehand. I wouldn't fold it, for them. I would let the students do that, but you can definitely cut the string for them. That way it's not something you have to worry about. If you feel like the plates that you're going to provide need to be flattened out a little bit, you can do that as well.
Okay.
All right.
So we'll go the second color here. We're going to trace these creases, and as we're tracing them, a lot of times in my class, students will say, oh, so I guess this would be like 45 degrees, and that's exactly what we're going for here.
Oh.
And as I'm navigating around the room, I want them to understand why we've chosen to do this. And the reality is, we're trying to connect a little bit to some geometry that they've studied. And they're special triangles, 45, 45, 90 triangles. Right, now that you have these new creases traced out, what we can do is label 45, 135, so on and so forth, all the way around.
Okay.
Yep. Use that same color. Yep, looking good.
So
Yep.
something like that.
Yep, perfect. And I think that's, it's beautiful because it's kind of like a work in progress. I don't think the students really, at least in my experience, ever care too much about, how their creases look or their lines aren't straight,
Yeah.
I think they get what we're trying to do here.
Yeah.
Okay, so we're going to do one more fold, and then the kind of the culmination comes about where we try to get the students to understand how this relates to radians, okay?
Okay.
This is a tricky fold though. So what we're going to do is we're going to fold it, again, we always start from our quarters.
Okay.
So back into our quarters again. So I tell students we know about the 45, 45, 90 triangle, but what about the 30, 60, 90 triangle, right? And that's kind of what we're trying to replicate here. So to do that, we have to take this 90-degree sector and we have to fold it into thirds. And this is where some of the moaning starts because they're not sure if they could pull it off. And it's tricky, it definitely is. So what I like to do is try to kind of eye up about thirds and try and fold it into thirds by maybe trying to make this crease here and then maybe try and pull the other one over it.
Okay.
It's not an exact science for sure. And then this is where I really tell them, press on it, press on it. You'll see students put it under their foot, they're stepping on it, they're just trying to make sure that they really exaggerate those creases. What you might want to do before you open up the entire plate is kind of create this little tray here to see if those creases came out okay, because before you go and really press down on them, maybe you wanted to just redo it once or twice more, So again, it's all up to the individual student. So when you're satisfied with that, we're going to open it back up. And as you probably can imagine, we're going to reorient ourselves here. And we're going to use our third color now to trace those new creases.
Oh.
And then label them 30 degrees, 60 degrees, 120. So I'll just go ahead and do that. If for some reason, and this has definitely happened in my class, if for some reason you have students who now have just totally lost it and the creases are indistinguishable and you can't even make them out, that's fine. Pair up with somebody who's they feel is pretty good and it's okay. I mean, they can kind of take turns doing what we're doing here. Let's go right back here. Now, in some ways, what we're doing, without really doing it, is we're also kind of introducing students to the notion of the unit circle. Now, we're a little bit of ways away from talking about that. We're not going to get into the coordinates and such, but at least they're starting to see, the makeup of it, the general makeup of it. All right. So this is what it would look like now when it has been completely folded. And like we said, I'm not going to label it here, but what we're going to do is label 30 degrees and 60 degrees. Maybe we'll just do those first couple.
I did a couple of the first quadrant
Perfect.
right there.
Yep, that's great. Perfect. Okay, so the moment of truth now, right? Why have we been doing this? So now why do we need the string? So this is why we need the string here. What I want students to do is I want them to start at 0 degrees. I want them to take a look. I'll probably even demonstrate in class. All right, so look at our string. It's 1 radius, right? What we're going to do then is we're going to kind of, go up here and wrap it around the plate. So let me just do it this way. Okay. And every time the string length ends, we're going to write a tick mark on our plate.
Okay.
And there's a reason for that. And then we're going to continue around the plate, going one string length to the next, making a tick mark every time it stops. So what I would do here is just trying to be as accurate as possible, not paying too much attention to having it be perfect. Going around the plate, I'll just do this 2 or 3 times. There we go. here's the thing that we really, really, really want students to notice. If you look at the plate, you make 3 tick marks just before you get to 180 degrees. And that's really significant. And the students probably don't know why at first, so you kind of have to lead them a little bit. So what we'll say is, okay, so what have I been doing is I've been tracing the outer part of this plate. What am I really working with? And so we want students to say circumference, okay?
Yeah.
If they can tell me that, then I say, well, what is the key element in the circumference formula or an area formula? You want students to say pi. Okay, so I say, well, what do you know pi approximated as? And everybody is up, 3.14, okay?
Yeah.
I say, take a look real quick. How many string lengths did you fit by the time you got halfway around that circle, right? And it was 3 with a little bit of space left over. Is it easy to imagine that that space left over could represent 0.14 of this string? Yeah, probably, okay? Keep going. What happens if you go all the way around, 360 degrees? Okay, well, they would have seen on their plate now 6 tick marks, right? I say, well, what do you think is the significance of that? And somebody eventually figures out, well, if I double 3.14, that's about 6.28, so 2 pi. So now here's the big connection, and I make them write it down. I say, then tell me what pi is equal to in terms of degrees. And I would say at this point, most, if not all, the students say 180. And that's exactly what we want. So I want them right away to put not only 180 equals pi, but I want them to also write 2 pi can equal 360. And so now they're making that connection, and we are beginning to show them exactly where radian measure comes from, right? So here's the final culmination of the whole plate activity. What we want them to do is start at 0 and go around, probably starting with the quadrantal angles. And I'll say to them, okay, so if we know that 180 is equal to pi radians, tell me what 90 is. And so you want to say pi over 2, right?
Yeah.
Tell me what 45 is. Pi over 4, right? And then I want them to go through every single degree measure that we have here and write the equivalent radian measure. And that's without me helping them. So I think if you start with the quadrantal, probably then go to the 45 multiples, I think by the time they get to the 30 degree multiples, it won't be as hard. But it'll be interesting for them to see things like 7 pi over 6, 11 pi over 6, those kinds of things. And we want them to reduce, right? Because we want them to be in their truest form. So that's a kind of the calculus, or the pi plate in a nutshell. The question now is, so now we've spent all that time on this activity with students. Where do we go? Well, we wanted them to convert. We wanted to do a couple examples, give them random degree measure, and say, okay, how do you think we would convert now if it wasn't on this plate? How would you take 200 degrees and make it into radians? And so this gets them thinking about pi over 180, 180 over pi, things like that.
And speaking of the conversion, something that I like to share with my students is just to have them try to make sense out of the formulas that they get for conversions. So when we're talking angles, we're usually talking relatively large numbers.
Right.
Or sorry, when we're talking angles in degree measure,
Right.
we're talking relatively large numbers, 180, 360,
Right.
even 30 is a pretty
Right.
large number. So when they're converting, well, do they want to multiply to go from degrees to angles by 180?
Right.
Or do they want to divide by 180
Right.
to get to the angle in radians, where it's usually a smaller number? So like pi is
Perfect,
about
yeah.
3.14,
Exactly, perfect.
2 pi is just a little bit larger than 6.
And that'll
So
be
that's-
good down the road
Yeah.
too, so they can kind of self-correct, and say, does this look reasonable?
Yeah, because they remember the formulas have something to do with pi and 180
Right,
degrees,
exactly.
but it's
And that's
which one
the
goes
thing,
where.
Right. So now at this point, they know that those two things are synonymous, and so they could use them going forward. So Brittany, tell us a little bit about where we can take the use of both radian and degree measure now.
All right, now we can actually go into applications.
Okay,
And so we can find arc length and area.
perfect. Perfect. And Gabe, we can also get a little bit more into the physics of things, right?
Yeah, so there's also applications that involve talking about linear speed and angular speed.
So I hope these tips have been helpful for you, and you find much success in section 4.1.